So this video will look at the third and last method of solving systems of equations, and that is using elimination. With elimination, we try to combine the equations using sums or differences, trying to eliminate one of the variables, like eliminate the x or the y. Sometimes this method may be pretty straightforward, as in this example, but sometimes you may need to multiply the coefficients by certain numbers to help in the process of elimination. So let's look at these examples. So up first we have, let's solve the following system, 3x plus 2y equals 14 and x minus 2y equals 12. Now right away, hopefully you notice there is something glaring at you that tells you elimination is the easiest method, not substitution. And that is that we have both a positive and a negative 2y. That will make for canceling y really, really easy. So I'm going to actually add these two different equations together. 3x, right, so I'm going to put a big plus sign here, and I'm going to add straight down. 3x plus x, that's 4x. Look at this, plus 2y and minus 2y. If I add those together, they just cancel out. Equals, and how about adding straight down 14 plus 2? That's 16. And I can continue to solve by dividing both sides by 4, and I will get that x equals 4. And now to solve for y, we can take our x equal to 4 and solve it by plugging into either of these equations. So let me make them a little bit easier to see. I'm going to actually use the second one because it looks a little bit easier, but either one will work. So that means we're going to substitute x equals 4 into our x minus 2y equals 2. If I subtract 4, I'll get negative 2y equals negative 2. And now if I divide by negative 2, I will get y equals a positive 1. So our solution to this system is x equals 4 and y equals 1. And that means that the point 4, 1 is our solution to this system, right? And the nice part is you can actually check your answer. If we plug 4 into for x and 1 in for y, we should get equations that are true. Here I have plugged in 4, 1 into the first equation, and we get 14 equals 14. And here is the 4 and the 1 for the x and the y in the second equation, and we get a true statement of 2 equals 2. Let's try another example. Right, here we have 4 minus 7y equals 13 and 2x plus 3y equals negative 5. Now, unlike the first one, if I add straight down, nothing will cancel, neither the x's or the y's. So you will need to use multiplication on one or maybe both of the equations to force that cancellation out. So let's look at the coefficients. For x, we have 4 and 2, and for the y, we have a negative 7 and a positive 3. If you look at both of those, can you multiply one by a number to get the opposite coefficient? Which one would be easier, right? Is it easier to make 2 become a 4 or really a negative 4? Or is it easier to make a 3 become a negative 7 or a positive 7? Well, definitely the 2 to the 4 is the easier way to go. And we can get the opposite coefficient of 4 by multiplying everything on the bottom. So I'm going to take this whole bottom statement and multiply it by a negative 2. That will then give me negative 4x, negative 2, and a positive 3 will give me negative 6y. And don't forget, everything needs to be multiplied by negative 2. So negative 2 times a negative 5 gives you a negative 10. And I'm going to keep that top 4x minus 7y equals 13 still there. Now you can see I've got that nice elimination process set up. So when I add straight down, the positive 4x and the negative 4x, those will cancel. Yay, we only have one variable now. Now if I add straight down, right, I'm going to put a big plus sign here because I'm adding negative 7y minus 6y, right? I'm adding them. They're the same sign. I'm going to get negative 13y. And if I add 13 plus 10, I will get a 23. We can continue and divide by negative 13 on both sides. So we'll get y equals negative 23 divided by 13. Not a great answer, but that is our answer. Now we need to find the x. So to find x, we need to take our negative 23/3 and plug it into either one of these two equations. I'm going to choose the bottom one because I'd rather multiply by a 3 than by a 7. So if I'm solving that, I'm going to get 2x plus 3 times negative 23 divided by 13 is our y equals negative 5. 2x minus 69 over 13 equals negative 5. I'm going to add 69/13 to both sides. That means I'm going to need to add it to the negative 5. I'll change my negative 5 to negative 65/13. Right? So now if I add these two together, I will end up with 2x on this side. And this will give me 69 minus 65. That makes this a little bit better. 4 divided by 13. And then if I divide both sides by 2, so I'm going to divide this by 2. And watch here, I'm going to just write it as divided by 2. But that really means if we do our keep, change, flip, we're multiplying it by 1/2. So that'll give me 4 over 26. Or actually, let me first go back. The 4 and the 2. Right, will cancel, and I'll end up with just 2 over 13 is my x. So my y value is the negative 23/13, and my x value is 2/13. And that means that our coordinate point that solves this system is 2/13, comma, negative 23/13. And yes, if you have time, you can always check your answer. You can see I quickly plugged our point into the first equation, and yes, it's not necessarily the nicest math, but it does work out to make a true statement or a true equation, 13 equals 13. So now let's look at the nature of solutions. Now a system of equations, as you saw the other day, can have one solution, no solution, or infinitely many solutions. Now most of the time we probably will be dealing with the one solution. That's where you're going to have two lines and they intersect in one place. If there is no solution, that's when you're going to have parallel lines, right? The lines never touch. When they're parallel, both equations will have the same slope, and usually you can find that if you start to solve for y, but they will have different y-intercepts. And finally, if something has infinitely many solutions, you're actually going to find the two lines or the two equations you have are really just the same line. And you can usually spot this algebraically when you're solving, when you get something like 0 equals 0 or x equals x. That's going to hint to you that you have infinitely many solutions. And like our parallel lines where you have no solution, when you're algebraically working with it, you may get something like 3 equals 0, right? There's no way that that's possible. That's going to be no solution. So let's apply this to an example and also decide on an appropriate technique to solve. So here we have a system. It's 3x minus y equals 0, 5x plus 2y equals 22. I might want to use elimination because here I've got a negative y and a positive 2y. It would be really easy to change this to a negative 2y by just multiplying by 2. Or it really is just as easy to move the y over and get y equals 3x. And now you could use substitution. Ultimately, the method you choose will be up to you, unless in the problem I say specifically show me elimination or specifically show me the substitution process. Why don't you pause the video and solve the system, and then I'll show you both examples. Here you can see using substitution, right, we end up with getting that 2, 6 is our x and our y. And then elimination, right, we'd want to multiply that top value, that whole top equation by 2, and then adding straight down, and we also end up with 2, 6. I would say the level of difficulty is about the same with either method in this case. Let's look at another example. In this example, we have 8x minus 2y equals 5 and negative 12x plus 3y equals 7. This one's a little bit harder because there's no clear, direct choice to make right away. If I'm going to use substitution, I'm still going to have fractional numbers, so I may try elimination. but there's nothing I can directly multiply one by to get the other equation. So I think I'm going to use elimination, and I'm going to multiply the top equation by 3, and I'm going to multiply the bottom equation by 2. Can you see why I'm doing this? That's going to allow for this middle part in here to be a -6 and a +6. So my top will be 24x minus 6y equals, don't forget to multiply everything by 3, 15. And my bottom equation, again, I'm going to multiply all 3 terms by 2. I'll get -24x plus 6y equals 14. Now, look what happens when we add down. If I add the 24x and the -24x, that will give me 0, right? They'll cancel out. And if I add the -6y and the +6y, I will still have 0, right? So both of these cancel out. I end up with 0 equals, and the right side will be 29. That makes a statement that's not true. So this is an example of two systems where there is no solution. And it's an example where those equations have the same slope but different y-intercepts. Let me change the equations into y equals. If I rewrite both of these as y equals, you can see my top one is -4x minus 5/2, and my bottom one is -4x plus 7/3. Same slope, but a different y-intercept. Again, no solution. You don't need to do this. Once you get to where you have something that doesn't make sense, 0 equals 29, that's going to mean there's no solution. Let's look at another example. So in this example, we have 3x minus 6y equals 12 and 4x minus 8y equals 16. I could try elimination again. I'm going to multiply the top by a 4, and I'm going to multiply the bottom by, I want that to be a opposite of 12, so by a -3. This will give me the top, 12x minus 24y equals 48, and the bottom will give me -12x plus 24y equals 48, or a -48. And now if I add down, what's going to happen? Cancel, cancel, cancel. So here's a case where you have 0 equals 0, because if you really look at these equations, if I divide the top by 3, what do I get? I get, let me use my purple marker, x minus 2y equals, if I divide 12 by 3, I get 4. And now how about the bottom? If I divide this equation by 4, I'm going to get x minus 2y equals 4. They are the exact same equation. So here's an example of no matter what, right, I plug in for my x and y to solve it, I'm going to get infinite solutions, because they are the exact same line. And remember, either way you approach this, right, if you end up trying to solve it and you get 0 equals 0 or 5 equals 5, right, that again is going to show you there are infinite solutions, because that statement is always true. Or maybe you did what we did at the second part. We noticed this is divisible by 3, this is all divisible by 4, and you get the exact same equation. That again is a telltale sign that there are infinite solutions. Either method will prove this. And either showing me this or this, and then with an answer of infinite solutions, is perfectly fine work. In class, we will practice elimination, but we'll also still practice substitution, because you really want to start to develop that. When is either one appropriate, right? Which one is the best method to use? Sometimes they're equally the same amount of work, and in some cases, one method is easier than the other. See you in class real soon.